Hi, we're in a set of videos about creating the graphics pipeline. In this one, we'll tackle the input assembly and rasterization. The input assembly is responsible for reading vertex data that we pass in, and then calling the vertex shader correctly using the settings we pass in. The rasterization step takes place after the vertex shader and is responsible for making triangles into pixels. We can start with the vertex input state create info. As per usual, we need to set the S-type to the VK structure type definition. Then we need to have the vertex input descriptions and attribute descriptions. For the first triangle rendering, we will not be passing any data. So we have no data descriptions and set both to 0. We will return here later in the course when we pass in data. Next, we set up the input assembly state create info. We need to set the S-type again. Next, we need to set the topology. The most widely used topology that you encounter is the triangle list. You can have more optimized topologies, for example, if you're drawing quads, but it is out of the current scope to teach you this. This topology means that we are going to pass 3 vertices that form a triangle. The primitive restart enabled we set to 0. It is not used when using any list topology and we're using a triangle list. This concludes the input assembly. We're going to create the rasterization state info next. Setting the S-type again, and these values are getting quite long sometimes. Now for the rasterization state, we're not going to clump off or cut off any triangles. You could enable the Rasterizer discard enable if you want though. We also set the polygon mode to fill. This is responsible for how to fill in a triangle. You can also draw only the lines of the triangles, if you're debugging a model, for example. In that case, you might set something like line width to 1. It will not matter if we set it for us though. The go mode is responsible for not rendering triangles that are facing away from the view. It determines the facing direction of the triangle front by the order in which each point of the vertex is passed in. If you pass them in a clockwise order, if they're facing away from you, you'll see them in the opposite ordering. We're not going to cull any triangles though, since I set the cull mode to none. Finally, we will also disable the depth bias. It is used for handling triangles that occupy the same space so that there are no flickering. This is it for these 2 pipeline stages.